Hello, ladies and gentlemen, boys and girls. My name is OctoMan, and today I'm going to tackle a procedural building creation, which means whenever you are going to have like different wall assets for a specific object or whatever, or for a specific let's say in a specific style. Then you're gonna go and create modular pieces in 3D. That's what they are called. And from these modular pieces in 3D, you are able or even allowed to create this. Let's say you can create a script which is automatically creating the buildings for you. And why can you do this? Because you know the distance between the particular pieces, as well as you are able to calculate the sizes, the height, the lengths, and anything else based on the actual modules you're going to create beforehand as a 3D artist. Modularity in general also works in 2D, so it doesn't matter at all. So modular means that each tile or each piece is allowed to snap onto another piece, so it's going to give let's say, a full design around the piece or around the buildings. So in my example, I'm going to use like these three wall types for the moment, and this is a corner type over here. We are going to examine them, well, not too much over here. And don't forget to subscribe to the channel if you haven't already, and you are following not my channel at the moment. Don't forget to subscribe to the channel. Feel free to ask anything inside the chat or even down below in the comments if you're watching this one later on. So don't forget that. Anyway, so this is a corner type. This is just a plain wall. We got a door piece, and we have something with a window in the top and at the bottom. I also have multiple other pieces over here, which means I have one single piece where only this window is here. I have another piece which only contains a window, because this one cannot be used in the second floor or even higher, because there are no, there is no cellar, there's no bottom part or like something below in the downside. So that's why I created some other tiles which are literally be able to place in a second, third floor and going upwards. Also, I have another door piece, so probably I'm gonna go and use them. Meanwhile, we are working around here to make use of, since I also created a balcony which is going to be around the door in the end. And the door is going to stay the same, so no changes literally over there. So, what does modularity mean, or what does procedurally mean? Procedural means something gets generated automatically. So you just give some basic inputs, like how much tiles could be changed, or randomly set between, let's say, choose a size between 2 and 10, for example, or 2 and 5. So the smallest amount of wall pieces should be 2, then our maximum is going to be 5, for example. And this can contain the width and the height, like the actual Z coordinate as well as the X coordinate, for example, here in Unity. So you can say, okay, how much should be the highest? Should it be 2 by 5 here as well? Then 2 by 5. So the smallest building we are allowed to get over here in the first floor, as an example, is going to have like a 2 by 2. So in total, we have a 4 meter by 4 meter small building. If we have that, we are able to continue on this one. So we are going to put these pieces based on where their pivot points are. We are going to talk about the pivot point in a moment. Based on these pivot points, which are literally at the bottom or somewhere where, like, if you want to move this tile, you're going to see there's a pivot point here on the ground. Based on that point, I know that since my pieces here are 2 meters broad, like from 0 to 2 meters real size, you can also see this based on the grid in Unity. So one grid unit is 1 meter by 1 meter in the real world. You are able to calculate that based on the pivot point. So we know, okay, when we start our building at 0, 0 in the wall space axis, we know that the first wall has to be at least 1 meter from there, but since we are going to put them a bit differently together, there needs to be a little offset to the corner piece we are going to create. So literally we can set the corner piece also directly on 0 when the pivot point of the corner piece is actually where it should be, like directly on the corner on 0, 0. So, and based on this knowledge, you can create such pieces as well as a code which is going to generate that. Okay, so I'm gonna need them, or I'm gonna use all of them for the moment. So for the first floor, we are going to take a look into the mathematics and maybe some small amount of editor scripting where we literally create a button to press on and we get automatically generated a new building, and we can store this as an example as a prefab, something like that. So we are going to take a look into that quite a bit. So you are literally allowed to create, every time you press that button, you can create a new building with new setup, with new amount of windows. We probably go and how much doors we want to put into at least over the complete floor or on either side or whatever. There are so many things we can put into that. So again, don't forget to sub up if you like that idea, if you like the video about this, as well as don't forget to subscribe to the channel if you haven't already, so you don't miss out anything. And there's a notification bell you have to press as well, I guess. Okay, so I already started to create just an empty building maker script. So you just right click, and create that. So what do we actually need to know? Well, as I said, we know the distance between two tiles because the tile size on my side over here is 2 meters. So I need to take this in consideration. But since Unity is not able to understand that as meters, we need to convert this into centimeters literally. So 1 meter in this case as a float is seen as 100, so 1 meter is 100 centimeters, and that's what we're gonna make use of, the 100 centimeters, since again otherwise we wouldn't be able to go in between the 1 by 1 grid, which is 1 meter by 1 meter. So keep that in mind. So what does it mean? We can make this infos public, we can make them private, doesn't really matter as long as we know what we are actually able to do here, or what we're supposed to do. So we need to know first, how long are my pieces? My pieces are 2 meters, so I'm gonna name that something like piece length or whatever. So that's going to be our measurement later on, because we can divide this number by 2 to find the center point, to find the pivot point, and so on and so forth. So we have a public float piece length. In my case, again, it's going to be 200F literally, since that is going to be a float. Then I need a list of pieces. I need a piece list. It can be an array, can be a list, doesn't really matter over here. An array of game objects, which can be where we can take prefabs from and put them into our play field, something like that. So wherever we want to position our building later on. So in that case, we can make use of a game object array. An array is defined by just these square parentheses over here. I barely use arrays, but for that purpose, that's totally fine, since we don't need to change the list or something like that, or change the array size. Literally, we just do this directly inside the inspector. So this is going to be our wall pieces list, or wall pieces array. Yeah. So for now, we could put in any wall piece. We can pick randomly from that array and can say, okay, how long that number we were choosing before, like in between a length of 1, 2, 3, 4, 5 pieces we want to place, we can instantiate them on the calculated position from 0. So we always go and start from 0. And we can also then, meanwhile, creating them or instantiating them, we are allowed to, or like copy them, we are allowed to place them wherever we want to. And we can also rotate them by 90 when we are creating the left side, the right side, and the back side of the building. So that's how it works, literally. Also, we can decide how much is the maximum amount of walls, or in this case, doors, for example, how much walls can be in one floor. Okay. So, we do have the piece length. And we do have the knowledge about the wall pieces we're gonna have over here. Okay. Oh, by the way, if you don't hear me or something like that, please let me know in the chat so I can do something against it. Anyways, we do know that. So what we now need to know is a minimum and a maximum amount. So we can put in an integer. It's going to be, what is the minimum amount of wall pieces we want to have? So min wall amount. This is per building. And we can, of course, we need to say it is going to be an integer type. We can set, if you want to, directly this one to be at least a 2 or 3. You decide on your own. Next one, we want to have another integer for the maximum amount of building or walls, literally maximum wall amount. Literally, it's not really a wall because the door is going to be counted in that as well. And we're gonna start with a 2 here as well. Now we need some functionality to actually create them walls. So we need to know, okay, what is the chosen amount of minimum and maximum, because we can randomize them. Like this one shouldn't be a 2, but should be, let's say, 8 or 7 or 6 maybe, or 5. Let's do a 5 first. So first off, the chosen amount is the one we roll for each wall. Literally, we don't roll that only for one side, but we need to do this for 4 sides. Or since the length of the building on both sides has to be the same, we need to say, okay, the front side and the back side of the building need to be the same amount as the left and the right. Otherwise, we would have like open areas. We don't want that. So we can, or we need to roll that dice literally twice. So we have like a front size, which gets rolled automatically, front size, and we're gonna have a back like a side size, so left and right side size, like that. So simple mathematics, right? Again, if you have any questions, feel free to ask them down below or inside the chat. Okay, so we do have the front side size, literally we have the side size. We can calculate them. Let's calculate them first. So since we do the same thing twice, or literally whenever you do things more than twice, it is better to set them automatically by using one and the same function. We just roll the dice with the same function, but we pass that number separately. So for example, we can say we want to calculate, it's going to be a return type int. And this is going to be, it doesn't have to be a public int, it's just an int. So we return int, and we say, we name this calculate size. And of course, open close parentheses, and we need to return something. So for the moment, let's return 0, so we don't have any weird stuff going on, or whatever. It doesn't say, oh, we need to just return 0 for the moment. How do we calculate now whatever needs to be requested over there? It's literally, we say, we create a new int over here, and I like a temporary. We don't really need to, but we can. It's like choose a random, whatever number that is going to be, or size that is going to be. The number is going to be equal to random dot range, and the range is going to be somewhere between the minimum wall amount, which is going to be 2, and the maximum wall amount. But the point is, to really reach the 5, we need to increment this by 1, because otherwise it is always taken, like random.range is never taking the highest number, it is taking the number given minus 1. So that's why we need to add 1 back. So just so you know. Okay, so, and this is the number we want to return. Of course, we need to close the line with a semicolon, and we can say we want to return number, whatever the number is we have calculated randomly over here. So this is where our procedural or randomness is going to come in place, because we just generate random numbers, pick random pieces, and place them anywhere in the scene, wherever we want to, literally. So in here we can calculate the size, and we can do this for the front size and the back for the side size. We're gonna do this whenever we do start the complete process. We don't need to do this beforehand. We just call front size is equal to calculate size. Over here we return a number, and front size gets any number between the minimum and the maximum wall amount we have picked beforehand inside the inspector. So next one is, now we want to loop through that amount, like over x and over z axis, literally, to place that things wherever we are with this length over here. The first piece needs to be created at the 100, not at 200, because the pivot point again is going to be inside the center. If the center point is not correct, then you need to create an empty game object and put that empty game object in the center, or at the very beginning of the building, and put the model as a child on this game objects whenever we create that prefabs, literally. Probably you have heard about that already beforehand. So let's create the first wall. We can do multiple things over here. This is going to be, the return type is going to be a void, and I'm gonna make this one public. We can also name this one create building. We can also name this something like create first stage. Why is the void type? Literally, again, it doesn't return anything. Like, it doesn't return a bool, a true or false. It doesn't return anything. It just does whatever is inside the void. It just goes through, performs literally everything it wants to, and then it, when it's done, it's done. So again, we now wanna, when we create that building, like when we create this function, the first thing we want to know is what's the size for the front and the back side, as well as what is the side size, like left and right. And that's what we're going to calculate over here at the very first place. So the front size is going to be equal to we're going to calculate the size, open close parentheses, close the line with a semicolon. And since we need that same thing for the side size, we're going to do the same. So we're going to calculate a side size. And now we got them. We know randomly between that two amounts what their size has to be for this newly created building. So every time we could even go at the very end and reset them back to 0 and so on. But that doesn't make sense and doesn't actually care about that. Or I don't care. So if we now create the first wall or the first building over here, we need to we can do something like we can create a new empty game object and put this onto 0, 0, 0, and every new created part is going to become a child of that. So later on, if you need to create multiple different prefabs of that type of building, you can drag that instantly because it's already parented to that object. So, and to do so, we can just say something like game object. It's like a new building. We can also even name that if we want to by whatever. And we say we're going to create a new game object, something like that. So now we can put anything onto this new building. We can also place that building. We can say something like a new building dot transform dot position is equal to vector3.0. So we put this directly onto the 0 axis inside the world space. Hi, I'm fine. Thanks a lot for tuning in, and I hope you enjoy whatever you see over here. If you have any questions, feel free to ask inside the chat, as well, don't forget to sub to the channel if you haven't already. So we do put this new created empty game object inside the vector3.0, like wherever the point is of the world space 0, 0, 0. Once we have done that, we want to put now the first, let's say the first wall. We can do that by taking these numbers for the front side, and we loop through that depending on that size from the left to the right. You can also go, the opposite. So How does that work? So I'm gonna comment this out. So we say here, this is going to be the first wall, the first front wall over here. So we loop through that. We can loop through that, boy, or it should be the best to use a for loop, of course. So meanwhile, we are looping through that letter I. We're gonna start at 0. The maximum, or actually in here, is going to be the smallest amount, is going to be whatever the front size is going to be. So front size. Since we are starting at 0, we are taking one number lower than the front size, because the element 0, otherwise we should, start at 1. But it doesn't make sense to do that, because we now need to multiply numbers times I to get the correct position of the first building, thing. Where do we do this and what do we pick? Well, first off, let's calculate the position. So where we want to place the buildings, the first wall, or actually each wall. So we create a new vector 3 POS for position, and then we can say where is that? And where that is going to be is from the new buildings transform dot position. And now comes the fun part. It's going to be, again, super simple mathematics. We're gonna take that. This is going to be XYZ position. So it's once again it's at 0, 0, 0, no worries. Next one is we now need to take the piece length and divide that by 2 and add the amount to our building's Z value, literally. So it's going to be plus, and now we can create, or we have to create a new vector which we want to populate that thing on X. We don't care about the y-axis or the z-axis. That again is going to be the depth of the building, like how broad that is going to be. The y-axis is going to be the up axis in Unity, so we only go over x. So we take our piece length, and we divide that by 2. So depending on how big your pieces are, you're gonna need to divide that by 2. If the pivot point, once again, if the pivot point is going to be in the center of the object. If that is not the case, you're gonna put this directly at 0 plus the piece length, depending on I over here. So we don't have the I yet, but we're gonna go and get there. So we don't put anything in the y, we don't put anything on the z-axis, so we could keep that at 0. So we just add to this building's transform plus the half size of our prefab. Okay, cool. I guess you get this. So super simple mathematics. Again, the current position of the building plus the piece length. What we can do is we are allowed to multiply things by letter I. We're gonna have to put this into, but we need to make sure that the I is not actually 0, because if we multiply something by 0, it always returns the 0 over here. So in that case, this is only for the first piece. The second piece and each upcoming pieces is going to be could not be multiplied by 0. On the other hand, if I just think about it, maybe we're gonna use I already. So if we multiply something by 1, it stays the same number. That's the simple mathematics. So usually you would say something like I plus, and then I multiplied by the piece length divided by 2. You can also do vice versa. If you put this into parentheses, this is going to be calculated first. This is going to be the most important thing. But on the other hand, we cannot do this, because if we are in the next steps, we need to take the full size. We cannot use that to divide that literally by 2. And this is the point. In that case, we would need to take the piece length divided by 2 plus the piece length. Interesting. So, and for doing that, we may go and rewrite that a bit different. So first off, again, we need to take the piece length divided by 2. That's the first thing. Then we need to add, and now we come into this nicely created or multiplied thing. So then we take I and multiply I by piece length and add this one to our initial thing. So how does that calculate now? First off, this is going to become 100. Then we add, this is always 100. The first piece always is 100. Then we take letter I. Again, if letter I is 0 and we multiply that by 200, as it currently is, it's going to return 0. So we add nothing to it. If it is the first piece, like 1, we're going to take the first piece length divided by 2, again 100 plus, and then we take 1 times piece length, it's going to be 200. If it is 2, like if I is 2, like the third piece in this case, we're going to have the same thing. We have 100 plus 2 times the piece length plus 400. So this is how the mathematics for the building calculation is going to be. I know it's a lot of mathematics, but that is what programming is about. Okay, now we know for each iteration, we now know the position in the z-axis. So no, in the x-axis, so like from left to right. Now we want to place something picked randomly and position that. And of course, after that, we want to make sure that we add to it, like we parent this newly created wall piece. So how do we do this? First off, we need to store this in the game object. Otherwise, we cannot, put things if necessary, like extra rotations if something is wrong with the initial prefabs, and so on. So maybe we're gonna do store that game object before we do anything else. So I'm gonna name this one new wall piece is going to be equal to. And now we can do something like instantiate, because that's what we want to do. We want to instantiate a random piece from this wall pieces over here. So we don't care about if it is a door type or not. So currently we just have wall pieces, nothing about doors. Okay, so what do we want to instantiate first? We want to pick randomly from that. So I'm gonna take random index as being a new parameter here. Index is going to be equal to random dot range between 0, so the 0th element in this array, and the maximum length of the array is going to be the last possible piece over here. So in that case, we're going to take wall pieces dot length. Because it's an array, a list would be wall pieces dot count. So it depends on what you're going to use. Now we're gonna pick from wall pieces, so this is the first one, at the randomly created index as usual. Now we can define a parent object, and the thing is we haven't positioned the new wall piece yet, so we would go and position this one first, so we cannot use the transform parent directly. So first off, we want to make sure that we position the wall piece first. In that case, we want to say that the new position is going to be a POS, because we have calculated this. Then we need to have a rotation, like quaternion dot. First off, I would say a quaternion dot identity. Later on, we need to go and figure out, like when it comes to the side pieces or the back side pieces, we cannot use a quaternion dot identity, and probably we can't even here. So maybe we're gonna create a new vector 3 dot Euler, which translates the rotation over here. Probably there is a transform parent over there, and now we can parent it to be a new building is going to be the parent. Dot transform actually should be the right one. We close the line with a semicolon. So again, we create a random wall piece from that wall piece array. We position that at the positioned, index, and we make it a child object of our newly created building game object, the empty game object we created beforehand. If you want to, you can also rename that building. Like you can say something like new building dot name. And then we can give it any name, something like random building. Whatever. It has to be a string, of course. So new building, whatever. I'm gonna save that script and let's return back to Unity and see if that already runs something. It can not be called directly at the moment because we haven't done that. So for the moment, for testing purposes, we can put this into the start or wherever, so it picks that automatically. Later on, again, we can go over and use something else. So I wanna edit the scripting so we can do this directly in runtime. So we can actually use that to create new prefab buildings as an example. So it starts. We want to create a building at 000 with the parameters we just gave it and see how often that works and how it looks actually. I'm gonna save that script, go back to Unity and let the compiler run, see if there are any issues, stuff like that. Doesn't seem to have any issues, which is good. So, and now I need to create some prefabs first. So I drag my cellar piece, my cellar wall piece, create an original prefab. I have a plain wall, gonna put this here as well. There are some weird rotations on these objects, so probably I need to do a fix for them. I also create a corner piece and a high door wall piece. Again, as you can see, there are these -90x rotations over there, that's why. And also there is this -180 because I flipped them all over. Okay, so let me create a new empty. It's going to be our building maker. You can name this whatever you want to. And I'm gonna put my script onto it like so. And then here we got the list for the wall pieces. Actually, it's an array, and in there I'm gonna put 3 of the wall types, or maybe 2, doesn't matter. I could even put the one with the door, and I'm gonna get rid of all of these things, at least for the moment. We don't need them. So we just have building maker over here. We have the maximum wall amount over there, and I just press play. Let's see what's happening. Let's see if it crushes or does destroy anything. Let's see what's happening over there. If nothing happens, well, then there's something wrong. But as you can see, we got a new building over here, and we can go down there. And these pieces are pretty small. That's interesting. So as you can tell, the first piece over here is going to be at position 100. The one we just created or we calculated. The second one is at 300. Next one is at 5. Next one is at 700. And the last one is at 900. So it was choosing a random number somewhere. I just don't know, and this is the fun part, if that is the correct way, or maybe that is because of these centimeters are wrong over here, and it's not like measuring the 200 as being in centimeters but in meters, which would be pretty weird actually. But let's take a look at let's take 2 instead of 200. I don't know if that makes any sense. Oh, we don't need to do this over here. We can do this directly here in that. Because this is the only thing I don't really know. Let's see if a 2 is more correct over there, because 2 meters instead of 200 centimeters. So we go there, and as you can tell, pretty good. Like everything is, of course, wrongly rotated because of the negative space, as well as the negative rotations I had before. So I need to do a small rotation fix directly in the script because, well, the problems are happening due through the rotation over there. So as you can see, every time I create a new or start the scene new, I got a wall. It's sometimes it's 3, sometimes it's 2, sometimes it's 5. I can do this multiple times over there. Like as you can see, it randomly generates multiple doors if it wants to, and so on. We can later on limit that by like pick only one door, but do change the index randomly or choose the index randomly where you want to place the door. But for the moment, that's pretty good. So we get there. If I open the prefab, you can see that there is no negative rotation over there, and it does take actually these numbers and zeroes them out. So what we can do is code-wise, since I know that, again, we can use an empty game object to fix that, which is also possible. Let's try that just to make sure. what we need to do is we create a new empty game object. We can name this whatever, wall 1. I zero this out. I make sure that there's no rotations over here, X, Y, Z. Gonna take the cellar wall window type and put this as a child on that. And now I need to reset this one to be at 0, 0 with the pivot point on directly where this wall piece is going to be. And now instead of the cellar, I'm gonna use or create a new wall piece. And now I can see it's going to stand up here. I can all create another one, wall 2. I take the high door, gonna make this child of wall 2. Wall 2, I'm gonna reset the wall 2 just in case. So go here, reset, high wall, gonna zero out X, Y, and Z. I don't touch the rotations, otherwise it doesn't really work over there. Gonna make sure that it's at the correct position and drag wall 2 now in here. Last one is my plain wall, so I can create another empty. Name this wall 3. Again, you can name this whatever you want. Take plain wall, make a child of wall 3. Reset this one, just in case, to 0, 0, 0. And of course, make plain wall 0, 0, 0 as well, so it is where the pivot point has to be. And I make this one a new piece. Now I can get rid of all of these wall pieces because I don't need them anymore. And instead of using my plain wall pieces here, I'm gonna choose wall 1, wall 2, and wall 3. And press play and see what's happening. As you can see, the walls are now standing directly where we want them. The new building is going to be created from the corner piece over there. And it created me a 3 by nothing, a front wall with taking care of, or without taking care of if it is having multiple doors or not. So as you can tell, this is going to be a pretty much interesting way to create buildings later on, automatically generated, especially when it is not happening in play mode, but also in editor time. Just think about it. Let's create the opposite wall pieces, because we need a backside, and these ones cannot be used by quaternion.identity. These need to be created by a negative rotation on the actual y-axis by 180 degrees, but taking the same parameters. So we can do this in the same loop, so literally creating a second piece, but taking the side size into consideration. Or we just do this separately, because it probably is easier to do this separately. So I'm gonna copy this complete part over there and put this at the bottom over here, and we say this is going to be the back wall, whatever that means. So again, we can calculate now the repositioning on that. So first things first, we need to know where that has to be. And in that case, we need to know the z-axis, which is going to be, this is the y-axis, this is z-axis, this is from our current position, from the building's position, the new building's position. We need to take the z value and add to it, depending on the side size. So in that case, we're gonna have to do that, the z calculation over, actually here. Yeah, so we're gonna put in side size because that's the maximum size over there. That's where we want to have the other ones. But does that really work? The downside is, again, when we go from a side piece on the left, we're gonna have to calculate the 100 first as well. Then we're gonna take the size of the wall piece and then the next one. And over there on the other side, we're gonna have like 100 from the left, 100 from the right, as well as all the in-betweens. So it's going to be the side size times, well, times what? That's now the question actually. So if we say we take the side size first, we can calculate and see this on to the grid and test it out in runtime as well. So first off, we create a new position based on the actual front size, because that's what we want to go through. We just need to rotate the pieces, go left to right. We want to go and use the same calculation over there, using the same size we have calculated at the very beginning of that, but we need to put this, whatever the amount is, the minimum is going to be 2, like 2 pieces or 2 sizes over there. But I guess this is going to be not correct in this case. We'll get there. We'll get there. I believe it's going to be the side size times something, but we'll see that in a moment. So we create a new wall piece at this point, like at the back side of the building, but instead of using quaternion.identity, we're gonna use quaternion. I guess it's Euler. So we can use something like a vector, you know, like a float, 1, 2, 3, or x, y, z float, like that. So, and this Euler, we can also use a vertex.vector3.Euler, I guess. We'll see in a moment. So, in here, we want to rotate over x 180 degrees. So, like counterclockwise or clockwise, doesn't matter. Then on the y-axis is going to go... no, actually, the y-axis needs to be rotated. The axis from left to right. The y is the up-looking axis, and the z is going to be the forward axis. Let's try. And what do we do? Of course, we put this as being child of the object over there. Again, if you're watching this, if you haven't subscribed to the channel, feel free to do so, as well as leave a comment down below, as well as give me something in the chat, like, do you like what I do? Do you have any questions? Feel free to ask down below. So, we do have now a distance from 1 to 3. As you can see, we have a 300, but my wall pieces are always 200. So there is no 100-ish piece, meaning we always need to add up, I guess, half of the size to the current size. Let's try again. Now it would be okay. I'm not quite sure what the chosen numbers are, so probably we're gonna take a look into them. Now we have 4. So let me check the actual building maker's calculation. So I can always go into the debug line over here, and the chosen numbers might be seen over here. So we see the side size is taken to be 4, and if that is a 4, we always need to take this 4, multiply that by the actual piece length. This is what we need to do. So we say side size multiplied by piece length, I guess. I'm gonna save that. So this is, so whenever we have 4 pieces or 3 pieces, it needs to give us another grid size to the back side. So now I have a, let's see, a side size of 5. So we need to have a grid size here of 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as you can see, these is the size over here is going to be calculated correct. Now we just need to figure out the sides of the building over here. Like we want to have like a window. Oh, by the way, the rotation over here works as well, because I rotated over y-axis. So as you can see, the green one is the y-axis over 180 degrees from the prefab's original rotation. That's why it matches over there. Let's do left and right sides, or sides. So in my case, we're gonna do literally the same, but we need to do the rotation a bit different, as well as the calculation is not based on the x, but the y-axis. So let's take the left side. So the left wall, left in case of wherever the what is it called? Yeah, left of the front side. So instead of using front size, we need to take the side size. That's the first parameter over here. So this is the iteration amount. As you guess, the letter I over here can be reused because we were closing the for loop over there, so we don't really go and need another letter. Only another letter is necessary if we go and have nested for loops. Then you need to do that. Okay. So the new position of our newly created item is going to be where? The x amount for the left size is always 0. I'm gonna cut this out. Probably I need this in a moment. The y one is going to stay 0 because we don't change height. So the z value is now going to become interesting. So what do we need to do? We need to take the piece length divided by 2. So the first point is at 100. Then we need to add I plus times the piece length again. So that should be the new position. Then we choose a random index as we did before. Now we want to instantiate that as the position, but now we need to rotate this. Now the question is it left-sided or is it right-sided? I don't know, so I take minus 90 and see if that works. Don't forget to save. Let's go back and see if we get side pieces on the left side and hopefully rotate it in the correct way. Let's see. Nope, as you can see, the rotation is vice versa, so it's completely opposite. So I need to do a plus 90-degree rotation in the script. No problem. It's because of the actual prefab setting. So if the prefabs are all set correctly or the same way, then of course it should be the left side, like outwards rotated, like that. Pretty cool. So now we have like 3 sides. Of course we don't have the corners yet, but we'll take care of them at the very end because this is, you know, pretty simple. And we're gonna have to fill now the right side of our building. Again, we don't care about the amount of doors yet, and we don't care about the inside ever. So we're gonna do the same thing for the opposite side. So in that case, we're gonna copy this complete stuff again and choose the right wall. Right wall. So we're gonna have the same thing, but now we need to again reposition that to be always at the full right side. And the full right side is going to be again the front size times the piece length. So in that case it's going to be over x. So over x we take the maximum front size, the maximum possible front size, and multiply that by the piece length. As we did the opposite here, as you can see. Here we zeroed this one out, and here we added to it. And now we do the opposite. We don't zero this one out, but we need to add to it. So it's from 0 to the maximum size, whatever the maximum size is going to be. And this rest is going to stay the same. So this is going to be like hopping upwards from the initial position of the game object, of the building's game object position. This is the newly created position or calculated position. If that doesn't match, then we change that. So front size multiplied by the piece length actually. Now we're gonna take, what actually do we take? We wanna create a new wall piece at the position, and now we can negate the actual rotation over here, and we should be done. Let's see if that works. I don't know. And that looks fantastic. We got the first floor done literally. We just don't have the corners. So when you now go up, we can literally do the same. We can run the complete code based on floor amount and literally go through the rest of that stuff all over again. But there's one difference. We cannot use that one door type. Why? Because, well, this is like a lead-in door. This is like not a balcony door or something like that. So this can only be used in the first floor and probably only used once maximum per side, like per wall size. Let's generate another one just in case, and just to see if that there are differences. So as you can see, now we have a 2x3. Gonna do it again multiple times now. So a 2x4, pretty good. So looks fantastic. If 2 is too small for you, you can always go in the building maker and say, okay, I want to have at least, I don't know, 4 sides per side or 3 sides, maybe up to, I don't know, 8. Let's try. Let's see what's going to happen. So this is going to be a 3x5. You can always see that in the debug mode whenever generated or calculated. You're gonna have an 8x3 now. Pretty awesome. That looks fantastic. So as you can see, automatically generated with just a bit of looping and coding, nothing fancy over here. Okay, so we can generate this. Let's add corners. I don't have a corner piece over here yet, so I need to implement this. If you have later on multiple corners, you can also say per floor, you choose randomly one per floor. You don't want to do this like over like the complete thing over here, like the complete, like you don't want to have random corners per floor. You want to have them like one floor contains one corner piece, depending on whatever the corner piece, let's say, design is going to be. Okay, so let's add one. It's just going to be a single game object over here. It's going to be my corner piece, since I only have one anyways. Gonna save that. And we want to make a prefab out of it as well, because it's laying down on the bottom as well. So I do, and oh, I didn't want it to cut that. I want to create a new empty. It's going to be my corner, and zero this one out. I go out of the debug mode, like go to normal, reset. Now I take my 3D model, wherever that corner piece is. Oh, it's in the wrong folder. No fancy issues. Gonna put this here for the moment. And I'm gonna reset this one to 0, 0, like that. So as you can see, it has only one specific rotation. The pivot point is going to be over there. This is important because it's easier for us to calculate where that corner has to be positioned. In that case, we can use full numbers times the size of the building. And then we just, per each corner, we just need to make sure that we rotate it into the correct way. So for the front one, we can test this one out. We have to do a 180-degree rotation over there, just for that corner piece. So I create a prefab first for this complete object, put this in here, and in the building maker I need to put this corner 1. Well, is it corner 1? It's pretty strange that it is called corner 1. Anyway, no issue with that. I hope that is going to be correct. I guess it's just renamed because the other one, the original one, is going to be laid down over there. Okay, so I guess I'm gonna delete this. I'm not quite sure. It seems to be a wrongly created prefab. Even the other ones, I should be able to delete them. I hope so. Like this, the ones which are laying down over there. Not quite sure. If that is not the case, let's see. Oh, they are emptied out now because missing prefab. Okay, then no problem with that. I just updated. The problem is with the, I don't know which one it was. That looks correct. The issue is I wanted to get rid of the other prefabs, and since they were inheriting the other prefabs, well, I wanted to get rid of them. So double click can open this ones. I had this one, so I'm gonna take this, hide door, delete this, and reset this one here to be 0 and 0. There's something going on here with the material. So I'm gonna go and check this pretty quickly out. It seems that this window box is going to miss its glass material, and same here. Looks good. Now we can close that, and we can go into the last one. You don't have to do this, of course. And this is going to be the plain wall piece. I delete this and reset this one here to be 0, 0. Pretty good, and looks correct, hopefully. So all the prefabs should be now updated again. So this, and this, and we do have the corner 1. And the corner 1 can now be renamed to be just corner, and should be good to go. And wall pieces 1, 2, 3, as well as the corner. Now, when we want to generate these corners into the actual corners, then we just can create a new function which just does that. So producing a corner per chosen size over there. And we can do this directly also here, like in the complete function. Usually you split things up as long as, or meanwhile, they are going to do the same things, depending on the actual input we're gonna give that. So literally, we could use that one for loop and give the parameters like over here to be the side size or even the backside size, and then do the same thing over and over and do the calculation over there. But I guess it's safer to make it by hand. Corners. So we do have 4 corners in total, and we do know all the positions. So the first one needs to be at 0, 0. The second one needs to be at 0 full size, times the actual piece size. The second one needs to be at side size, but 0 on x, so 0 and side size. And then the next one is side size, the front size, comma, the side size, like, so we do know them. And also, depending on that step, whichever that is going to be, we're gonna need to rotate them accordingly. So what we can do, since we need to do literally the thing 4 times, like per each iteration, but the positioning is going to be always different. So we cannot we can 4 times loop through, but to check which index that is going to be. But it probably is easier to just calculate the 4 positions and take the pieces directly and create them. So in that case, I would say we calculate the new position every time, like 4 times in a row right now. Maybe we can do something better. I don't know. It's going to be a POSA for position A. The position A is going to be at new building transform dot position. So nothing has to be changed. And then whenever we now create the new game object, the new corner, actually we need to put this together. This is just the name, is equal to, and now we instantiate our corner piece at the position we just calculated, position A. And now we need to figure out the new corners, or the quaternion, the rotation of that. So quaternion dot Euler. And now I would go and say on y-axis, I would try 180 degrees first, because the initial rotation is like backwards. And then we can also put this as a parent object to the building. So actually new building dot transform. So which is going to be the parent object over there. So this is for the first position A corner. Let's save that and see if that works. So that should be now directly at the correct position. I don't know about the rotation. We'll see. So as you can see at 0, 0, this corner is over there. There's one thing I haven't checked yet. And actually, all these pieces are wrong. They are now all inverted. Why is that? Like each piece now is inverted. Usually it should be the opposite. Let me test this again, because something seems to be strange now. Okay, so each of them pieces is now inverted, like like 180 degree, like the opposite. Why is that happening? I know, because I was rotating the pieces, like the actual prefabs. I changed them. Oh my god! So I need to do like a 180 rotation, but not on that, it seems, and not the wall. We need to do this like internally over here. That's what I did before, without knowing. So the high detail wall here needs to have a 180 degree rotation as well. Plain wall, same thing, and 180. It seems that the plain wall does not have any any materials. Actually, it's not taking the correct ones. So I guess this one and this one, they seems to be the, yep, that looks better. Okay, so do through this rotation it was wrong. So now I can put in the corner again, and then everything should be pretty much correct now. So if you encounter any things, try to fix the bugs first before you are allowed or able to go forward. Why? Because if you go forward and code and code and code and code and you don't check, you'll probably never find why or like what are the reasons for that. So now we can see the corner piece over here goes straight or directly inside this piece over there. So where this empty corner has been before, there's now the filler object for that particular corner. The rotation is correct here as well. And the first one is going to be looking pretty good. So second one would be that one. That means it needs to have a rotation by 90 degrees instead of 80, because I guess it's going to be clockwise with that rotations. So I copy this thing, copy, paste. I could even manipulate the position A, but let's take position B over here instead. And new corner A, new corner B. We don't really need that. Game object thing, we could even say we just instantiate them. So position B is going to be the initial position plus the offset plus new vector 3, and we are going to the right, so we go over X. So we take our current position plus, and now we add again. The 100 is going to be the actual piece, but I guess we just need to say we need the front size, and we need to multiply that by the piece size, piece length actually. Then for the y-axis we're gonna stay at 0, and then for the z we're gonna stay at 0 as well, because this is going to be in another step, like for the opposite corner. Oh, I forgot to rotate it. So I guess it should be 90 over here. Maybe it's a negative 90. I don't know. We'll see in a moment. So probably it's going to be clockwise rotation automatically, because it has a 180 already. So as you can see, we got the second corner in place. Pretty good. 90 degrees is going to be like clockwise. Over here we don't need to do a rotation, because that's going to be a negative or nothing rotation. And let's go forward with that. It's pretty simple as well. We just literally we just copy this one over here, and that's going to be the position C, and this is now going to take the front line or front size times the piece length, and then here it's going to be this side size times the piece length. Pretty good. And now we do not need, I guess we don't need any rotation, and it's going to be now here corner C, and of course we take the position C. So this is important, and we could, if we want to, if you don't want to check that, we can also go and take number B over here, number D, or the corner D. So position D is literally staying at 0 at the front size, because we are going just up, but taking the complete size of this side. We rename this one to be a corner D if necessary. And the position C is not correct. We need to take position D over here. And this needs to be, I believe, a negative 90. Counterclockwise rotation, literally. Let's try. Pretty good. So now our complete bottom floor, including corners, is done. Of course, we still have a lot of door or walls with doors inside. Doesn't matter, at least for the moment. We can take care of that later on. If you do have buildings which do have like an in-between piece over here, I have some in-between pieces over there as well. I haven't imported them yet, but I can do in a moment. You can go literally do the same thing, but use the in-between pieces and the corner pieces for this as well. Now let's take a look. Let's screw that, because I guess you get the idea of that. let's think about how could we get a second floor or even more. So literally, if we gonna get what we need first for a second floor is we need to split the wall pieces and the door pieces a bit up. So literally multiple floors, or let's say instead of wall pieces, we can say something like this is the first floor wall pieces. So on the first floor, we can only use them because there's this cellar window in the bottom and so on. And maybe I'm gonna implement another piece which only has windows on it, or a balcony piece and so on. So for that, you can go and create just something like, okay, this is for the first floor only, the selection of items, and the second one and everything above is for the third and upcoming ones. So in that case, we can say this is, I just rename it because it's easier and I don't need to go and fix all that. So I go and rename to first floor wall pieces like this. And probably do I need to do it again? I guess I'm gonna put a P with a big letter in between so it's easier to read in the inspector. So, and then we can have another list or another array of not first floor pieces, but let's say other floor wall pieces. So, but the first. So not the first, but anything else. So we can put in any other ones. So. And what we do is we literally do the same thing. We just need to lift and we need to pick different items. So, and now this is the question. How would you go into that and pick now, not from this, but from that, without repeating all the code? I mean, you just create a second function which only, instead of picking from the first wall pieces, it's going to pick from other floor pieces in that case. How do you do this? Just think about it for a moment or two and give yourself an idea about it. And what would you do? What is the array literally you want to pick, and how do you want to do this? Well, the question is answered literally easy. We can always put in as an argument and game object array whenever we want to start that. We can give any array. Let's say the floor pieces to use. We can give it any name. Floor pieces to use. So we can pass in, for example, when we call this at start, we say we want to iterate through that multiple times. So we have like a random index request. Then we call this per iteration over the floors, and if that is not the second or actually not the zeroth index, or if it is the zeroth index, then we're gonna use the first floor. Otherwise, we want to use that one array to pick from. Instead of first floor pieces over there, we're gonna choose or use floor pieces to use, and now we just change these indexes over here, or these requests, these usables over there. So we use the argument instead. And we're gonna use the corners as well because, well, all the other floors are going to have the corners as well. Let's see if that still works. We use the first floor index over here. I'm gonna start a new run. And now it tells us building maker out of index. So probably I do have a change or changed something over here. Ah, yes, because I renamed that and I lost all the prefabs over there. So, which is cool, since now we can say, okay, this is a first floor piece. This one here is going to be the door. It's a first floor piece as well. So that can only be used on the first floor. So I'm going to put this in here. In the second floor or other floor, there's this window piece. No, it's a straight wall piece. This is the only piece which is currently, at least, allowed to be in the second floor, but it can also be used in the first floor. So we can have multiple settings, multiple floors as being in an array to make use or to get used. Gonna save that and try again, see if that still creates my walls. Looks pretty good. Now, next one is we want to iterate through that because we want to say, I want to have a random height of the building. So I want to get any number. I'm going to store this number int building or just a height. And the cool part is now, if we don't have any in-between piece, we don't need to calculate that in, like in between like these ceiling pieces or something like that. And even those can be put it on top later on as well. So I have a height. My piece height, public, it's a float, I guess. Piece height is equal to 3. I know that because I created them. So the height of the piece is 3. So we need to lift all the newly created pieces by the floor amount times the piece height, always. If it is at 0, then of course we don't touch that. But when we don't do this, that's something we probably want to put in here inside an argument, for example, because we always go over there and loop through that multiple times, and we need to say, hey, what is the current floor we are actually in? We can do the calculation over here beforehand, but, and this is now the fun part, we cannot do this like every time. We can only do this once. So literally, we're going to have to change the setup so that we only do this once per iteration, literally. So this one here, instead of being create a building, this is literally only creates a floor, not a building. So because we want to create multiple floors. For each floor, or actually for each building, we want to calculate this once and go through that complete building piece. So I create another public void, create building, open close parentheses, and in here we want to say how high is that and what's the size about that. So before we do this, we try out, and actually the newly created building piece over here has nothing to do with our actual floor. So we only want to create one building at a time, so we want to do this over here as well. So first off, we need to know what is the actual building we created, so we need to pass in the actual building as a parent. So in that case, we can say, whenever we call create floor, we want to say, okay, what is our building first? So we pass over a game object and call this new building. So we don't have any issues with the code over here. So we create a new building whenever we call create new building. We take this out of start, and I take this and bring this over here at the very first place. And so the first thing we do, the first iteration now needs to know the new building, which is going to be the newly created game object. We pass that over so we can put in the other components onto that new building as an argument. Second one over here is which floor pieces do we want to use. So this is the first argument over here. We don't go further now. We first off want to check if we are still allowed to create a building that we wanted to do. So open close parentheses, close the line with semicolon, it's start. We want to see if that still works before we go further. So let's see. It still works. So we still get a new building. We get all our wall clones inside this building pretty good. So we now can make use of that. That's awesome. Next one is we want to now put in the floor. So how high is our building? We can probably name this to be floor amount. And the floor amount can be also, let's say we're gonna create a minimum and a maximum value over here. We can also say something between, and then we can say something between 1 and something. Let me copy that. we're going to put another one. It's going to be minimum height amount. So we want to have a minimum amount of 1, like we do only one iteration, and a maximum height amount could be, I don't know, maybe 5 as well. So we can lift up pieces by 5. So this is the iteration amount. So the first one, the first floor, is always at index 0. So literally we should put in maybe a 0 as being a smallest amount. Not quite sure we'll get there once we are struggling with the iterations through that. So what we want to do is we want to do set our floor amount. Floor amount. And this one is equal to, and now we don't use calculate size because it uses a different minimum maximum amount over here. Otherwise, if we want to use that that function we created beforehand to calculate the site, like this one here, we could also say which things, like which how shall I say, which numbers to be used over here, so we can pass in the corresponding amounts over there. So like min comma max should be of course, let me put in something like int min comma and then an int max. So, and then we can use min to be here and max to be there, and now we call this based on different scenarios. So for example, this is used from or for the min wall amount, so we're going to pass in min wall amount, comma, and then the max wall amount, and same thing for the site size. So we can copy this and paste it over. And this one here is going to not use minimum wall amount, but it's just using the minimum height amount. So I'm gonna use them actually. Copy and paste. So maximum wall height or height amount, maximum height, minimum height amount, min wall, max wall. So now we can still use the same function to do the calculation for us, but still, you know, we don't waste much time. We just need to pass in the correct parameters for that. Now we do have the floor height. We can now put this into a for loop. So for int I equals 0, while I is smaller than the floor amount. This is a question I don't know yet, but we'll see that in a moment. Meanwhile, we do so, we want to create a floor like that. But we want to do if I is equal to 0, then we want to use the actual floor or the first floor pieces. And otherwise, like else, we don't want to use the floor pieces. We want to use the other wall pieces. And now we're gonna be able to create any height, I guess, of a building, but all the other floating wall pieces will be empty wall pieces because there's just nothing on it. Let's see if that works. So we do have a 0, it seems, so it doesn't create anything. Let's try again. Okay, so the new building now is completely empty. Why is that? Let's see. Minimum amount is going to be 0. So if I is smaller than the floor amount, and I guess the minimum number should be at least 1, as I guess. Save. So somewhere in between 1 and 5. And in building maker, I guess I need to put in a 1 here as well. Let's see if that works now. So this is going to give us in return a 1. I can also go, and this is the fun part, I should be able to see in debug mode which one has been picked. The floor amount which has been picked is a 1. Let's try again and see if there's another one happening, because it was like multiple times now. And now we can see the interesting part. We haven't implemented the height yet, because we don't know. We haven't put it in. It created a second floor, but it created this at the very bottom. To calculate that in, we need to know the current floor height times the actual number, like the what shall I say? Yeah, the floor height times the actual height amount of the actual tile. So the 3 over there. This is what we haven't implemented yet. So to know where we are, we need to pass over the index or the height or which floor it is currently we are using. So int, I name this one current floor, something like that. So currently all our y-axis over here are going to be 0. What we need to take is current floor and multiply that to be the full height, multiply that by our actual item. What we can also do is we can also calculate the height already, like floor height. We can pre-calculate that, and instead of having the zeros everywhere on the y-axis where we do calculate the new position, we can pass over the floor height directly in the y-axis. So over here, everywhere where we are creating the new positions. This also is important for the corner pieces. So we need to lift them up if needed. In that case, we do have position A over there. So we need to lift it up if necessary. In that case, we're going to have to say plus new vector 3, and this is going to be just the y-axis. So literally over here, we need to say floor height, the one we just pass over here. And we need to do this to all of the other ones here as well. So in that case, here it was just for the first one because it was at 0, 0, 0. So we need to add this one here. But in the other ones, on the y-axis, we need to put in the floor height here on the y parameter as well. Don't forget to save. That should be good. And in here, we now need to pass in the floor height. So we can use I times the piece height. I don't know if, yeah, the piece height. And I times the piece height is going to be actually not really necessary for this particular one, since that should be just a 0 for the first floor. But the second one and up is going to be, or should be, I times piece height. I'm not quite sure why this is going to be that. A float in an int is not possible. I times float. Oh, that needs to be actually a float. Pretty good. No issue with that. Just needs to be a float instead of an integer. Okay, so that looks good so far. I'm gonna save that and let's see if that makes any difference now to our complete building setting. Look at that. Pretty good. So we have now a fully functional building creator. We don't have a rooftop, but you get it, I guess. It's pretty simple to put in a 2 meter by 2 meter block, or calculate the size of that and position that, you know, half the pivot size, and put this directly on the top of the highest height over there. Again, if you have like in-betweens, you need to always implement the in-betweens over there as well. Like if you want to put in some window pieces instead of these wall pieces, or you want to randomize them or whatever, then you can just put them into the other floor wall pieces completely together, so you don't have any issues. Let me find pretty quickly some other buildings models. Literally, I just see a window plane wall over there, so I'm gonna put this in. And I need to set this up first. So I create a new empty, window it, wall. I can name this whatever I want to. You too. Put this in here, make this a child, and make sure that I zero this one out, 0, 0, 0. And this one here local position, I'm gonna go into normal, make this one a 0, 0, 0, and here I need to rotate by 180 because the rotation for all the pieces are going to be literally the same one. So, and now I go and create a prefab out of it, put it in here, and in my building maker I'm gonna be able to put the window type there. I don't know if the materials are correct now, but we'll see that in a second. Ta-da! Now we got a windowed wall inside that building as well, and yeah, it looks pretty good, I guess. So modularity and 3D combined with some coding possibilities. Again, we didn't touch the actual door amount yet, but you get the idea, I guess. So now you should be able to produce hundreds of different buildings. Let's do one more step, the last step actually over here. Again, you can create by code a cube, resize that to a size of 0.2 times whatever the size of the mount is, and put this directly in the center of that as a rooftop and lift it up as depending on how high that has to be, so you always have a rooftop if necessary. Again, once again, if you have a ceiling like something which is a bit higher than that, you can also put this on top per each floor, or you can calculate that as being a door a floor type, something like this. You just need to define the height of that piece, so everything else is stacking up onto this ceiling piece as well. But I don't want to go over too much. I guess you get the idea over here. So what is needed to make this one working directly here in the inspector, and this is probably the most interesting piece now. So we can create on button press without being in play mode a new building on 000 and make a prefab if we want to. How does that work? Well, we're gonna be able to use editor scripting. I need to create a new script for that, otherwise it's impossible to do this. And I create a new C# script. I can make this or rename this building maker editor, something like this. I need to close that pretty quick. Need the compiler run, see if that is the correct one. It is, and open this one up pretty quick. And there are multiple possibilities for us to do that, to actually do the overall things over here. So first off, it's an editor script, so we need to inherit editor. But as you can see, editor is not represented over here, so we need to put in using Unity engine. No, Unity editor actually. That's what it's called. Gonna put in editor here. I'm back in 1 second. Okay, let's go forward. Don't forget to subscribe to the channel if you haven't already, and feel free to follow up. And don't forget to ring or tip the notification bell over there if you like what you see, and yeah, to get notified when something going on or new is going on. Okay, so I'm gonna have a editor script, and editor scripting is a bit, let's say, it's rather simple once you get the idea behind it. So first off, we need to tell the script that it is a custom editor, and this custom editor has to be related to some other things, like a type of, in my case it's going to be the building maker. This one is the other script we are relating to. What we also want to give ourselves, just in case, the can edit multiple objects parameter over here. And that's the most important things over here, I guess. Now we want to override the inspector. In that case, we need to say something like public override void And usually we get something like on inspector GUI, this one. We don't need the base on inspector GUI. It's just here for whatever reason. We don't need this. But what we want to do is we want to target this building maker. So just in case. So we're gonna be able to, yeah, question is, do we need that? I don't know. Let's try. In here, we want to say that the building maker, we can actually do this probably. A building maker, this one is going to be our new I'm gonna name this maker. Maybe it's going to be our new target, the target for our onInspector GUI thing. We need to typecast this one to be our building maker, and we name this target. The target in that case means it's a special character. That mean this is a special condition over there. So this is the inspected, as you can see, the inspected target. So this one. So we need to typecast this one, why-ever, into building maker. I believe because it's usually an object. Yeah, that's why. So what we now want to do is we want to create a button to create a building. So the easiest one is, not quite sure if we need to have any GUI layout and stuff like that, but before we do this, let's do this first. So if GUI layout, so we can put in a layout, and in what can we do? We can create a button like this, and then open close parentheses, we can give that a label, a name, or whatever, something like create a building. So, and when we press that, what do we want to do? We want to run the function create building, this one. So usually we do that at start. I just make sure that I comment this out just in case. I want to say something like target, or in this case it's not target but maker dot create a building. I don't know if that works, but we'll see in a moment, right? What we want to do also, we want to see if that works, of course. Probably you need to change some code here and there because the instantiate probably doesn't work directly in editor or in editor time, but we'll see. Probably it still does work. I don't know. So when we press a button in our GUI, we want to do create this. Now we can, since we cannot use any anything else, we first off want to see if there's a change we have done. So we're gonna, just in case, say something like editor GUI dot begin change tag, and of course end the line with a semicolon. Once we are done with that, we want to end that. So we want to say editor GUI dot end the change tag. So if we have done any changes, and what we can do is probably we need to we can say something like editor utility dot set dirty, and what do we want to set dirty is going to be the target, right? So so what does set dirty make? It makes an object literally dirty, or it marks it as being dirty, so it means it has to do something with it. And finally we want to draw the default inspector. That means whenever we draw that default inspector, we're gonna see the old settings inside the building maker again. Beforehand we wouldn't do so. And at the very top we should see a button. Well, that's what I hope. So let's see. Nothing actually works here, or nothing shows me that one button. So let's see, maybe there is some changes to that, or maybe it's not the way it works anymore. So before I go further, I want to see if I gonna disable this door default inspector. I want to see if that they are hooked up, like if they are hooked together as they should. There we go. So I just needed to declick and click again. So we can now see create a button building, or a building button over there. And the building maker, we don't have any changes. We don't have any possibilities to do any change. So for that case, we'd need to go and draw the default inspector. So I'm gonna save that again by, and then we should see the button as well as all the settings we just created beforehand. So we can put in any things, and if we want to, we can put in some spaces and yada yada yada. If I now click that button, you can see magically we created a random building, a new building over here. And now the cool part is there are some downsides to this method, by the way. All the prefab connections are gone. So if we do a change over here to the world prefab itself, which is the functionality of being a prefab, if we do this method, it still works, but if we do a change to the prefab, these pieces do not listen. They don't listen anymore. But this is the first, or let's say the easiest and simplest way to get stuff done quick. Now what we can do is we can create prefabs out of this building. So I take this building, put this in here, boom, and I got a building. Super simple. I can always go and put this in here. I can rotate it. I can place that wherever I want to. I can move along. I can go not in, but I can place or create hundreds of buildings. How does that work? Well, I just click a button. I have a one size building. I have another size building, another one, another one, another one, another one, another one, another one. And the ones which I like the most, I'm gonna take and use them. That actually looks pretty funny. It looks like a staircase, as you can tell, and everything is like in between the other in-betweens, but looks cool. I mean, that could even be another building just out of other buildings. And so you can see we have like multiple possibilities, multiple buildings to be set up and created procedurally. Procedurally, again, that means we gonna have the issue or the possibility to create hundreds and thousands of buildings in a split second just by button press. Again, the prefabs currently don't have any connection, but that's okay, at least for the moment, for testing purposes. So as you can see, I can create a town in literally no time. And each of them has a complete different setup, a total different amount of windows. And if you're gonna put in some, floor tiles, as I said before, and even a rooftop if needed, well, what else do you need? So this is literally hopefully the shortest way to explain how that is going to work. Like, how does it work to create a city with just some prefabs, with a bit of coding, with randomness, and yeah, you can create hundreds of new. Just create, click. If you don't like it, destroy it, delete it, and make a new one. But you know what? Let's do the last thing. Let's put a rooftop on top over here, because a lot of people maybe don't know how you can do this. If you don't have any tiles, like if you don't have a rooftop tile, you can create one directly in Unity. Of course, there's an issue with that. They might not be textured, so you can also use a prefab otherwise. So how does that work? Well, it's simple mathematics, as you already know. And by the way, you can also do this like each floor as a fill. So how does it work with a rooftop? Well, as you can tell, this has a size of whatever, 5, 2, 5, 6, 7, whatever the size is. We need to create a roof tile which has a size of 1, 1, 1, and we multiply that by the amount over here and place that in the center of this complete object. So we take half the size here to position that. Then we need to know where to lift that to, so we can easily create a rooftop. We could even put a floor plate around it, like for a street or something, which is just 1 meter in all of the 4 directions based on the center point of the object. So how does all of that work again? Let's go into code, because, well, that's probably the last thing we need over here. Oh, and by the way, you can even do this with other things, right? You can even go with with street pieces. You can create streets and bridges and stuff. You can create a complete town, literally. Like, if there's something not on this and this and this and this and this space, then put a building, a random building with the size of whatever the space is at this position. So you can automate all of that. You can build a super huge city. You can even put water and any other objects inside the scene, so you can fill this super quick and super much, actually. How do we create a rooftop? Create roof. Let me create a prefab first, so we only need to go over X and Z axis, and we don't need to struggle with the height of that. Okay, so first off, I create a new 3D object, a cube. This cube is going to be our roof prefab. This roof prefab gets from me a scale in the y-axis to 0.2, so it's like rather slim. It's not a 1:1:1, it's a 20 centimeters height. If you want to have a higher height, well, go for it. If you want to create a material with any of your wall textures you're gonna have over there and use them. If they are seamless, you shouldn't have any struggle with that. I don't know if mine are seamless, but I guess. So I could even put in like this gray texture on that. But screw that for the moment, it's not necessary. What we do is we create a prefab from that roof, because we need to use that, we need to rescale that. So it's important now that your scale X and Z is staying 1. If you want to, you can set the XYZ of that cube over here to 0, 0, 0. Actually, I did this directly now inside the prefab, so we don't need this roof anymore. What we need is something to put this roof into, like our roof piece, so we can put this directly in the corner area if we want to. So like behind or below that. So this is going to be our public game object roof prefab. Again, you can put in anything over there, not just that, or roof piece. Up to you again. So when we got this, we know where the front size is, we know where the side size is, we know what the floor amount is, and whatever the current amount is, we know how high our building is, and we can negate it by whatever amount to have it like a little whatever hangover or something like that. And we can put in anything, or we can put it like 10 centimeters, since we know the height, 10 centimeters down, so it's not looking over the complete piece over there. Okay, so how do we do this? First off, we need to instantiate this, then we need to rescale this, then we need to reposition this. Okay, first off, we create a new game object, our roof. After we are done with all the floors and all the other stuff, we want to instantiate this. So instantiate, close parentheses. What do we want to instantiate? We want to instantiate the rooftop, like the roof prefab. So now we want to know where that is going to be. So I'm gonna put in a new vector, because we want to calculate this once. So we can already calculate the center point of our building, wherever that is going to be, as well as the height, as well as the scale. Well, the scale is going to be a different one. So let's talk about vector 3. This is going to be the scale. I just make a new vector 3. For the moment, I go for 0, 0, 0. And then we need to have a position. So vector 3 pos equal to new. Let me just copy that. Copy and paste. The scale, by the way, has to be applied afterwards, after positioning. No, beforehand, actually. Oh, actually, it doesn't matter. We can position this first and scale afterwards. So we need a position. So, and in here, we're going to say, okay, we put this at position, and the rotation can be quaternion dot identity, because we don't need to rotate this. And if we want to, we can also parent this one to be part of, new building dot transform. if we want to. It's not necessary, but for checking, maybe you don't want to start with connecting this over there. So this is going to be our roof. Afterwards, we're going to be able to, or we have to say roof.local scale, or the scale transform.local scale probably is going to be the right one. Local scale is equal to scale. So whatever we have pre-calculated beforehand based on the numbers. So this one here, we don't want to touch that. So we want to take roof prefab dot local, actually it's a transform dot local scale dot y. We don't want to touch y, so that's why I'm gonna take this and keep it. If it's not possible, I can say I can set it by hand to be 20 or whatever. So now the x scale needs to be the full size times the like it is the, what is it called, the front size multiplied by the piece length. Front size multiplied by the piece length. The Z value, the one which is going to be and then in the, you know, away from the camera, is going to be the side size multiplied by the piece length. So now we know how big it has to be. This is, now we need to position that thing. So in Y, we are going to use the floor amount multiplied by the height, by the piece height. Piece height in our case is 3F. X is going to be the front size. And now it's going to be interesting. We should, I believe so, we need to use the piece length. We need to divide all of that by 2, I guess. And for the Z, we need to take the side size times the piece length. Probably I'm wrong. The piece length divided by 2. That should be the size and the scale for the roof. Let's see if that works. I have no idea. If that is too huge, then we know there's something wrong with it. If not, well, then not. So we were creating all of these things, but there's another reference exception, and this is probably because I haven't put in the roof prefab over here. So I'm gonna put it in. Gonna delete this new building and create a new one. Boop. And ta-da! Our building got a roof with the correct size, automatically calculated by the, you know, by all the inputs we were getting here. We're gonna have the size of 20, so it stays 20. We can select it and can see here it stays 20 because I was setting it inside the prefab, and it is calculating a 12 by 12 over there. So this is going to be the size for the roof. If you need to, or if you want to, put this like a bit down, like so. So you have like a little ceiling or a little, you know, a little gap there. You can just bring it down by, let's say, 10 in its full height. Walkable rooms. Hey, Yanni, thanks a lot for tuning in. Yeah, why not, right? Walkable rooms would be a rather simple one, as long as, first one, you're gonna have pieces which to have openings here, and then you need to also put in like staircases, right? So like where you can move up, and this is something you can put in as well at any time. Literally all the floors like here are nothing else than a roof. So as long as, and this is the piece, like as long as you have an opening. So and depending on this openings, it can be anywhere, right? So you probably find a way to mask out that areas so you can pass through. But the as you probably guess, is you need a rigid body or a collider, literally, which is going to give you the possibilities to push or move through. So, or you're gonna get a pass by this meanwhile you're on a stair. Something like that. I guess you get the idea. So literally what we could use is a mask to mask out areas which are not rendered. That's the thing. Maybe a shader could do, I don't know. Mask that areas out. You can put this randomly, so you have at least one staircase per something, or you're gonna go in and yeah, do it by hand, but that's not the purpose of the video, right? So this roof can also be a floor. That's the first thing I wanted to say. So meaning I can put this even here at the bottom. I can even put a floor like, as I said before, like a street or a side over there. This is just a simple cube. I mean, you can think of going further over there. I don't know what's happening when I put a scale on a material, or when the material is scaled, but probably if we put in material, we need to scale this by the amount over there as well, so otherwise it might look wrong. Anyways, to bring this one down, like let's say 20 centimeters or whatever, I just put it down. Yeah, about 10. You can do so by, well, where is it? By repositioning it downwards just a bit, like by 10 or something. So in our positioning, where we have the floor height, we're gonna say minus a new vector array, and you can define the height on your own, comma, and let's say minus 0.1 f. This is like 10 centimeters, comma 0. Is there any issue with that? Why doesn't it let me put it in? Maybe I'm gonna have to put this into parentheses. Usually it's not. In mathematics, usually this is put it first. Float cannot be in a vector array. That's why. So we don't need to put in a vector. We just need to put in the actual amount. Because I haven't split it. Actually I splitted them up beforehand, so I didn't put it directly in. Pretty good. So let's try again. I get rid of this building and create a new one. Now it's brought down half its size, as you can see. So what we could do instead of half size, since again I want to go another 10 centimeters down, so I'm gonna put in a minus 20 or minus 2 here, or minus 3, and depending on if you are in the actual calculation from the building's window. Like if the window is higher than mine over here, you may encounter seeing the rooftop through the window, like it may go an overlay over there. Let's try again. Make a building, and now we got a slightly brought down piece over there as well. And yeah, again, if we are going to get in floors, we can do this per iteration, like not just the roof, but in each floor literally, but the roof has to be an extra over there as well, because the last floor is ending here, like calculation wise. So you can put in that one, just multiply that, do a throw using another for loop as an example, or actually not even needed a complete for loop. We can put it into the currently existing one, in this one here. So what we can, instead of using that, we can put in this rooftop calculation over there. We can use that and outsource that, as well as put in whatever the current height is. Like over here, we just take the full height. Instead of that, we can use any other calculated height. Let me bring in another one, which is going to be the floor. I want to create a floor which is 1 meter by 1 meter bigger, like 2 times bigger, of our building, and put this into the negative space. Like a street. Create street around the building, just to make it beautiful and finalize that. So how does that work? Well, we take the scale and we calculate all of this, and I add a 2 to it, like +2, like so it is like 2 meters bigger, like in the front and in the back. what we probably need to do is we need to take the size, or this calculation for the positioning, and take this one as being the center. Otherwise it might be not centered directly, because the size probably is a bit different, but we'll see in a moment. Maybe not. Okay, let me scale this 2 times bigger, or 2 meters bigger. So plus calculation comes always after multiplying. Why is that now not working? Oh, yeah, because I have them already. I literally can override them, I guess. Maybe this is going to be our street. I don't know. And this way you can also do the other ones. Just you need to loop through the floor amount over here. My height of this piece, I take the same. I take the roof piece, but I want to put this into the negative space. So from 0 down below, so it's under the building, literally. We could also lift the complete building, and so this one would be at 0, 0, 0. So we create a rooftop prefab, position this one over here, resize that +2 in X and in Z. We keep the scale size over there. We could even implement a new material just for that. As well as for the roof, we can put in another material on for that as well. It's not like rounded cornered, but you'll get the idea. Once you get a rounded corner piece, you probably are able to put this on there. Oh, I don't need to press start. I just need to generate one. Oh, this is funny. This actually, it makes what it should. It positions it just not at the floor. And why is that? Because it's taking the original one. It doesn't pre-calculate or recalculate this. Actually, it's taking the height from the current position, it seems. So we're gonna take. Let me create a new one. It should be here. Let's see. New building. This position over here seems to be kind of wrong. How do we do this? It's going to be new building dot transform dot position minus new vector. I believe it's easier. Instead of using this 0, 0, 0, and in here I'm gonna use -0.2 f, because that's a complete size over there. But that doesn't work. So I need to catch that that position first, it seems, or that single position here, or just put it into somewhere else. The -2 over here, or I create a new vector 3 PSA, I don't know, or S, POSS for street, vector 3. Let's see if that makes any sense. Maybe I was just doing the wrong step. What I mean by this is I probably was by using this old. I haven't used the new one. I guess that's probably why. Let's see what is happening here. Why is there now this reddish issue? Oh, there is something missing. This POS position is going to be. Why is there parenthesis already? That doesn't. So we have the first parameter. Oh, there's another 0 in between here. So now we should be good to go. Let's try. Maybe it works, maybe it's not. We'll see in a moment. Oh, I don't need to press start. I just go to my building maker and hit create building. It still puts it over there. It's putting it like 11.8 down. Oh, this is like. Okay, there are 2 ones. Oh, I forgot. I don't have to press that. Let me get rid of that. I just want to check what the second roof is going to be about. So at the very bottom, we got the first roof. This gets rescaled. Oh, yeah, I know why. And this one is at the correct position, but it's not scaled. That's why. I see. So instead of putting the local scale from that, I need to put this onto the roof. Like, on the street. On the street needs to be rescaled over here with this newly created scale. So I'm not rescaling roof again. That's the first thing. And the repositioning seems to work fine. So let's try again. Don't forget to save in between often so you don't lose anything. And let's get rid of that and create a new building. And there we go. And yeah, if you want to put in any other stuff. Why is that now? That seems to be pretty low now. I guess it's just 0.1 now. Like 0.1, since the size of that is the half the size where the pivot point is going to be down. I don't know. Let's try again. I just changed it to -1. There we go. Now we can put in any materials and you can do showcase. That's a huge one. We got a roof, we got a floor, and if you don't like this just 1 meter from the center point, you can always put in, I don't know, more. So in that case we can do something like 4 instead of 2 in the size, like to rescale the floor or the bottom over there. Don't forget to save. And let Building Maker make another building for us. Nope, that's the wrong one. And we can put it in here. And the cool part is, if you have like street pieces here as well, you can snap them together. Like, you take just the V key and snap them together, and then you can fill a bunch of things. Let me get rid of the first building over here and create a new one and another one. So we can we can snap them together and make a ultra beautiful town over there. There's one more. There's one floor to that. It's this building. This building's pivot point is still over there. So the roof and the bottom are going to be. The roof is okay, but the street has its own pivot, of course, but it doesn't follow it. It's just the empty game object we were creating in the process. So that's it, I guess. We can put in things next to each other. We can make a beautiful, that's interesting. We can make a beautiful town. We can make huge towns, small towns. And we can snap things together if we want to. I don't know, sometimes it works, sometimes it doesn't. And you can make huge streets with different cool buildings. And if you wanna go a step further, then you store what you got. And for example, get from the inside to the outside and build buildings, like generate buildings around it. So you don't really go, with each building separately, you would now create a bunch of them. What you can do now is, you can generate them and stack them together, as I currently did. Then you can put your street view. That's actually wrong. Like so. Well, I hope that works. Yep. So you can make beautiful towns. You can make that even more automated if you want to. So in the end, you can generate really, really nice ones. As Yanni said in the chat, if you want to go a step further, you might be put in some collisions already to doors. For example, if you can enter a house with a character, with a 3D character, something like that. So whenever this prefab, this door prefab, just needs to have this collision, right? So you can play an open animation, and you can let people pass by if you have that. And so if you get into the one first, or you want to get into one first floor, then you can do so if you do put open floors. And the best way would be have two particular floor tiles. So instead of having one tile, you're gonna go, hi Rohith, thanks a lot for tuning in. It's hard to spell your name. If you want to put in something like floor tiles, you go with a 2x2 tile, like each of them is going to be 2x2, and you fill them the same way. And you keep one open for where the staircase is. And in there, at this point, you're going to put in another prefab which contains the staircase. I guess that makes sense because you already know now how to put in streets and stuff like that. I mean, that's super easy, right? If you have the correct textures on them, you can do for that. You can put in separated texture, stuff like that. But and same here, you can even put in some extra building pieces onto this building. Like if you have a super small one with one door, you can even put this by hand, of course, but you can even automate that. Put in like a 1x1 or a 2x2 as an extra rooftop thing, like if there would be an elevator inside this building, something like that. So I just laid down a base, and you can think of how could you extend this. Like, how would you go and create a full town on one button click? What do you think? Can you do this? Oh, I've renamed this one. Could you do this? Yes or no? I believe so. Because you know everything. You know the sizes of these. You can stack them next to each other. And you can put them into or next to each other, like, okay, you have created one, then place that in the next free spot. You can do some extra in between checks, and then you can fill in a huge area of buildings next to each other. You could even go and take these and just duplicate them. I mean, who holds you, right? Who holds you back? I mean, of course, this is now a bit handiwork, but you get the idea. And then you just take this selection and snap it to the next piece over there, and everything fits, and you can build up from here. And if you have, again, if you have something like where you're gonna go through and some cool scenes, maybe you just have a camera flow to that, then you can do so. And yeah, once you're inside and your camera is set up correct, you can make beautiful shots if you need to. Again, you can put in textures, thousands of them, and make your scene even more beautiful. And you can put in content inside each building separately. And you can put this like on a 2x2 tile. Say there's one bed on this tile, there's one set of something on another tile on a 2x2 meters something. So you can go into, you can put in any office content and so on and so forth. And what you can do is you can even go and do something like take other tiles for different buildings so they don't look all the same. You can do something like with a brick wall, like a brick wall building. Again, this is something where you just need to figure out how big are the tiles, how big are what are the necessary settings for the building maker, literally, to create a building. You just need to know what's the piece's length, what's the piece's height. They always have to match. Once you know that, you can do the same thing to each individual piece. Even smaller ones, even bigger ones. Maybe I'm gonna make a church. I mean, think about it. How beautiful could a bunch of churches be if they are, or just one single church? I mean, what do you need for a church? You need like 5 to 10, let's say maximum of 10 different things, like tiles or assets or wall pieces, with and then you just need to know the size. And by the way, if you have multiple different sizes, like piece height, for example, you should be or you can also read the tile size automatically based on if you put in like a, what is it called, a collider on it, and you can read the size, the boundaries of the collider, and then calculate from this point. So there are hundreds and thousands of possibilities. And if you need multiple piece height For example, if you have like an in-between thing, I haven't put this one in yet, but if you decide to put something in between, like beautiful somethings, you can do so as well. You just need to have an extra piece height, like an in-between height, and then you need to put this into the complete calculation here as well. Guys, that's it for this live stream. I hope you enjoyed this one. I hope you learned a lot from that and how easy it can be to create a town with just some simple, or let's say rather simple settings. I don't go and cover the prefabability stuff yet, because that would need us to go further down into editor scripting. So we would need to, instead of using the script outside of editor scripting, we are just calling it by instantiating things, stuff like that. That's why we lose the connection to that prefabs. But in another video, probably I'm gonna go and cover this, how to keep them. Or if you want to find out, you can see that in the Unity scripting reference there are a bunch of things. So it's basically all about editor scripting in the end. If you want to go a step further, then teach yourself, get a bit more knowledge about editor scripting. So instead of calling these functions directly in the editor, like directly in the building maker only contains the values over here, but the functions should be called directly in editor scripting, like in the editor script we were creating beforehand. So super simple stuff, literally, if you know how. And how to create a prefab is, there is something called prefab utility, yada yada yada. Just check it out on the Unity scripting reference. You will find out, I guess. Once again, thanks a lot for tuning in. I hope you enjoyed the stream. If you have any questions, feel free to put them down below in the comments. Don't forget to give that stream a thumb up if you like what you see. If you have any further if you have any requests, feel free to request them somewhere, maybe under this video or anywhere else, and probably I find a way and the time to put in new content here on this channel. So I hope you enjoyed the stream. Don't forget to sub to the channel. If you need any special help, you can hire me. Go to my website octomangames.com and do so. And that's it. Thanks a lot. I hope you enjoyed this one, and stay safe and have a good day. Bye bye.